Good morning, everybody. Welcome back to lecture number
43.
43. We have 44, 45, and 46. Lecture 46 is to substitute the founding day, which almost all of you missed it, except 3 or 4 students. So last time we gave this example. Do you remember this example? So let's do it one more time. What is 29? 0, 0, 0, 1, 1, 1, 0, 1. What is 27? 1, 1, 0, 1, 1, 0, 0, 0. If you want to subtract them, you have to get the 2's complements. Ramadan. What's the difference between 2's complements and 1's complements? The difference is the 1's complement, you just flip every digit. So the 0 becomes 1, the 1 becomes 0. For the 2's complements, we're going to do it now. For the first, you start from right to left. The first one you see, up until the first one you see, you copy. So how many, where is the first one we see? It's the first digit. So we just copy the first digit. Everything past the first one from the right, we flip it. So what this will become? 0, 1, 0, 0, 1, 1, 1. So now you're adding the 29 plus the 27th complement. This is the 27th complement, which is minus 3. Is it minus 3? No, not minus 3.
2 complements, minus 2.
No. 2's complements. Let's look at this thing. You copy the first 3 digits in this example because the first one is the 3rd digit. So everything you copy, everything else flip. The difference between the 2's complement and the 1's complement is just by adding number 1. But the problem, if you add 1, you will have carries. So to avoid the carries, if you do this trick, you don't need to do it. Other solution is just find the 1's complement and then add 1.
Oh, yeah, but the 2's complements, what's does for the numbers? Is it subtract from 2?
Okay, what is 0, 1 complement? Regular 1's complement.
1, 0.
1, 0. What is 1, 0?
2.
2. What is 0, 1?
1.
Okay. What is 2's complement for 0, 1?
1.
So 3 is the 2's complement for the 1. 2 is the 1's complement for the 1. Okay? But don't look at it that way. Look at it that I need the 2's complement to do the subtraction. Okay? So doing this example, what is this number, ya shabab? It's in the sign 2 complements. This is minus. In the sign 2 complements, remember, the sign 2 complements, the table, the most left digit is for the minus. Everything else is for the 2's complement. So what is this number? 1, 1. Ignore the first one. Any calculator? I don't know what it is.
101.
101? 101?
Yes.
What is the, okay, with the last one, how much? This is not much. And what is this number? Is there any relationship between 101 and 29 or 229 and 29? I mean 27. Between 27. What's the relationship between 27 and 101? There is no relationship. So the 2's complements doesn't have a direct relationship.
بس هنا يا دكتور حطها minus 27 ما حطها.
You're right, it could be, yeah. Anyway, let's do the addition for now. Don't think about it deep. 2's complements is used to do subtraction process. خلاص؟ هي المكمل لعملية الطرح من هذا الرقم. Whatever this number is subtracting from is the complement. So خلاص يعني don't worry about it إنه هل هو بيكمل للاثنين بيكمل للعشرة. So 1 plus 1 0 carry 1 1 plus 0 plus 0 1 plus 1 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 0 and carry 1. What did we say about this big one? You ignore it. What is this number in the sign to this one? This is plus. Okay? Let's do another example.
لازم نعدل الديجيت يكون نفس الأب.
Yes. This is the digit number 9. So you ignore it. How many digits do you have here? 1, 2, 3, 4. We usually want to do 8 digits because of the sign 2's complement. This system, the first bit from the left is taken as a sign. Okay? This allows you to do operation from minus 28 up to 1 plus 127. So if you get number 300, you need more digits. So let's do this exercise. Find the 8-bit sign 2 complements for 22. What is 22 in binary? Well, it is here.
1 0
1 0 1 1 0 1 2 3 4 5 6 7 8. Okay? Is it positive or negative? It's positive. So you keep it using this format, okay? Okay? 0 0 0 1 0 1 1 0. How many bits? إذا هو negative, like minus 30, you first find plus 30. What is plus 30?
1 1 1
It is 4 ones and zeros. So how many bits is that? 5. You make it 8 bits, okay? And then you take the 2's complements. Question the quiz. This example, 7.6. VIP. 0 1 1 1 1 0 0 0. You take the 2's complements. How do we take it in Ramadan? You copy up until you see the first one. So this is 1. No, this is 0 1. This is copy. Everything else flip. 0 0 0 1 1 1. So this number is what? Minus 30 in the signed 2 complements notation. Okay? Is it correct? Yes, it is correct. Exercise. How do we do 19 minus 4? The same story. The positive number, you keep it as it is. The minus number, you take its 2's complements and you do addition. Okay? Remember, we don't like عملية الاستلاف in the binary numbers. Okay?
دكتور
What is 90? Yes.
شو يعني أطرح على طول بطلع؟
Okay, let's try to do with your... No, what if you have point? What if I say there's no calculator in the quiz? Well, there will be a calculator on the quiz, but if I give you point something, can you do it?
البوينت لازم أحسب.
البوينت هي تخرب كل شيء ولا يعني. It's better to do it. What if we brought you... What I usually say? Alpha, gamma examples. What is the alpha that makes this thing? What is the gamma that makes this thing? What is 19? 0 0 0 1 0 0 1 1. Okay? What is minus 4? What is 4 in the 8-bit notation. 4 is what? 0, 0, 1, right? So in the 8-bit, it becomes this number. 1, 2, 3, 4, 5, 6, 7. What is the 2's complement? Copy the first 3, flip everything else. And then do the addition. 1, 1, 1, 1, 1 plus 1, 0, carry 1, 0, carry 1, 0, carry 1, 0, carry 1, and you ignore the last carry. What is this number? 15 or 16? 15. Okay, plus 15. Clearly, 19 minus 4 is 15. If you want to do your method without taking the 2's complement, how are we going to do it? It's harder. Yeah, you can do it. I will try to do it, but it's not easy.
Doctor, the last time we don't always ignore it, right? Not always.
You ignore it if it exceeds the number of digits in the subtraction process. Okay? Sometimes you will have 1, 1. If you subtract small number minus big number, you will have 1, 1, 1, 1, 1 without carry. Yeah, for example, if you do 27 minus 13, the answer is minus 3. If you add these two, you will get minus 3. Though, note that these ones will go, 1 will go, and 0, 1 plus 0, 1 is what? 1 carry 1, 3. Yeah, but Turkey's point is pretty much interesting, so let's try to do it without the sign, to do subtraction. 1 minus 0, 1, 1 minus 0, 1. 0 minus 1 is what? We don't, illegal. 0 minus 1, illegal. So you need to take from this, carry it here, this becomes 1, take from this, put it here. How many carries? كم سنفة سوينا؟ 2. تلخبط. 1 minus 1, 0, and then everything else becomes 0. Those two carries, the carry in, is not hardware implementable. What's the answer? 4 or 3?
When you take the carry, it will become 2.
1.
The first carry it will be 2.
Okay. When we take this one, this is what?
1.
1, 1. And then we take from this, it will become what?
1 يكون 1 هنا.
يعني 1 هنا 1 هنا.
لا راح تكون تاخذها تصير 2.
الصفر 1.
Come do it.
عندنا 1 نستلف يكون 1 ناخذ ال 1 هذا نوديه 0 يصير 1 minus 1 0 وننزل 1 عفوا يكون
See,
1 1
okay. So this is 3.
1 minus 1 1
2 minus 1. Okay.
من الصغر لما يكون 1 1 هيصير كاري وتصبح.
What is this one? Is it 2 or 3?
بناخذ نستلف يكون 1 1 تمام 1 هيروح وال1 الثاني هيكون كاري اللي هو ذا 1 مع ذا 1 هيصير 0 ويكون 1 هنا كاري.
So if you take from this one, we'll have 1 here and 1 there. Okay. Is it easy? So do the 2's sum. Please. خلاص؟ لأن الاستلاف من الخانة البعيدة بيعطيك 2 ones as you just mentioned.
وياخذ 2. هو
Yeah.
أخذ 1.
يعطي 2 and yeah. Okay? We don't want to do it. Stick with the process, okay? Trust the process. واضح يا بسرعة؟ You took this in the lab, so let's cover it real quick. For your information, the last section that's required in the exam is 7.3. Section 8 is for your knowledge, okay? 7.4 is what? For your knowledge. ما راح تجي أسئلة عليها في الامتحان. 7.3 is including 7.3 is the last thing, okay? So we call the logic gates also combinational logic circuits. In this section we consider logic gates. It has multiple inputs and we usually expect a single output. either 0 or 1. The AND operation on two logic variables is actually A and B. The condition is both of them has to be 1. So for C to be 1, both of A and B has to be 1. اللي هي بالعملية المنطقية 1. The truth table for AND is it's only 1 if and only if A and B are both 1s. If you have 3 ANDs, the only output becomes 1. يا أبو نصار. If and only if A and B and C are 1. Okay? Here are some of the mathematical properties, Boolean properties, مش mathematical, Boolean اللي هو المنطق الرقمي. A and 1, anything, any variable, because A can be either 0 or 1. So if you add 0 with 1, the answer will be 0. If you add 1 and 1, the answer will be what? 1. So 1 is like a pass. It will allow anything. If you have one application, if you have AND gate that has 3 inputs, and you want to use it to pass whatever variable you have, you put here, for example, A, 1, 1. So the answer will always be A. If A is 0, it will be 0. If A is 1, it will be 1. So this is one application of the ones in the hardware, okay? If you add it with 0, you kill everything. In Boolean algebra, it's okay to have A here, B here, or here, okay? And then you can do it, you can do AND B and C, and then AND everything with A, or AND A and B and AND everything. وتصير خاصية التجميع. وش خاصية هذه بالعربي؟ الإبدال. هذه الإبدال وهذه تجميع. The inverter gate, whatever you put, the opposite gets in, gets out. One of the properties, if you put A ANDed with its invert, for example, in the circuit, if you have A and you put A prime, you will always get the answer 0. Because one of them at least will be 0. That's how to think about it. ونفي النفي إثبات. Okay? نفي النفي إثبات. If you have 2 nuts, يعني one application, if you have A, you put an inverter here, what is this? A prime. And then you put another inverter, what you will get here? A. نفي النفي إثبات. Okay, what about OR? OR gate is not an addition, but we give it the symbol plus. The OR gate, if you have only one high voltage signal, it will make the output high, regardless. And you can see this from the truth table. As long as I have ones in every row, I always have the output of 1. Is it clear? Do I need to spend more time or go to the tougher ones? Let's go to the tougher ones. How do I memorize these properties? Well, you don't have to memorize it, but over the time, Khaldi, over the time, better. Over the time, we will practice, okay? How many of you from the other section? Okay. Don't forget, okay? You have to wait. If you OR with 0, you'll always have the same output. Why? Because if this is 1, you'll always guarantee to have 1. If you OR with 1, you'll have always 1. If you OR with the invert, you'll always have 1, because at least one of them has to be 1. If you OR the signal with itself, if you have 1, it will be 1. If you OR the signal with itself, and both of them are 0, the output will be 0. وهذه خاصية ايش؟ تجميع، وهذه خاصية توزيع الأور على الآند. ما هي توزيع الضرب على الجمع؟ توزيع الأور على الآند. You start with an and then you split it as 2 ORs. So this will be A ANDed with B, or A ANDed with C. Don't read it plus يا صادق والسلمان, okay? Sadiq Salman, this is not and, this is not plus, this is we say A ANDed with the OR combination of B and C is A ANDed with B, all ORed with A and C. A and C.
دائما الضرب او اند
ما هو ضرب.
الجمع اور والضرب.
اللي شكله زي الضرب and واللي شكله زي الجمع or. But this one, the right way to read this is A. The right way of reading it is A. You first do whatever inside the parentheses. So you OR B and C. And then the output, you AND it with what? A. You OR B and C. The output, you AND it with A. It is the same as having two AND signal, and this is OR. A and B, A and C. That's the output. So you start with whatever in the parentheses, and then you split it, okay? So Boolean algebra, it's named after the scientist George Boole. It is not like the ordinary algebra, but you only allowed to have three operations, and, or not. Everything else is neglected, and the best way to deal with it is using the truth table. For example, prove the associative law اللي هو خاصية التجميع for the OR operation, which states that A or B, everything OR with C is same as A or with the OR operation of B and C. If you do the inputs, always 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. That's the right way of doing it. 0, 1, 0, 1, C's, it'll be 0, 0, 1, 1, 0, 0, 1, 1, أبو نصار. A will be 4 zeros and 4 ones. The intermediate signals, check A or B and B or C. So A ORed with B, 1, 1, 1. So 0, 0, 1s. B ORed with C, 0, everything else is 1 except these two. And then you do the OR operation between A and this, or C ORed with the red one. And this is the output. Now we can prove that all the outputs are the same. So this property is true. So if you get stuck in the exam, you don't know what is the right property, do the truth table. Okay? This is another way, another table. We prove A ANDed with the OR operation of B and C. So we always do the inputs in the blue. Intermediates, المتوسطة اللي هي في النص, which is B, whatever you need. B ORed with C, A and B, A and C, you put them in the green. And then you check the output. So how many outputs? You check the right term versus the left term. Are they equal? Yes. Then this property is true. Do I need to do it in details or it's self-explanatory? Another operation is find the truth table for A ANDed with B or with C. Again, this is the inputs. You start with the C. Always start with the C. 0, 1, 0, 1, 0, 1. The B we should see 0, 0, 1, 1, 0, 0, 1, 1. The A, 4 zeros and 4 ones. And then do the intermediate. How many intermediates you have? A and B ORed with C. So this is A and B ORed with C. You put it here. And that's your output. Did you take it in high school? So no need to explain. Good. Can you do this? You know that how many variables you need? A, B, and C. But I'm going to tell you what are the columns, what columns you need to make. Then you do it yourself. So what are the intermediate columns? where you need to do AB and then AB prime, and then you need to do A, B, C prime. So you do these two, and then you order them. This, OR with that. The key here is you can't find this directly. You need to find AB, then you invert it. After that, you OR those two columns, and then you will get your final answer. Any question about it? عدد الروز هو 2 to the power number of variables. How many variables you have? A and B and C. Usually 3. If you have 4, that's a disaster. Usually 3 in the exam. Okay? And of course, here don't forget the A, B, and C, okay? And that's how to construct it. That's the proper way of doing the truth table. Okay? Do you think this is an MCQ friendly exam? Yeah, the final exam is MCQ. Okay? But it's a useful feature to check your answer. What is important in the final exam is either he gives you the circuit and tells you write the expression. So he'll give you a circuit and he tells you what is this expression. And he'll give you 5 different expressions. And it has to be simplified. And that's the best way to study for the final. But before we that, did you see what I just made before? I implemented this few minutes ago. Do you remember it?
Yes.
I told you this is A and B ORed with A and C. This one is B and B or C in parentheses and with A. You start with whatever in the parentheses and you expand out. عملية نفس أي عملية رياضية. You have to do the parentheses first. الأقواس أول بعدين وسعها. Any question about this? See this disaster. So we have a disaster here, right? How many terms do I have? That's the first question you need to ask. I have 1, 2, 3, and 4. And then this one would make it like 5. But that's not the deal. The best way to write it is you have to check. Did he ask you find the simplified version or just implement this without simplification? In this example, we are not simplifying. In this example, I have to start with whatever in the parentheses first. So I have to have 4 gates at level 1, 2 gates at level 2, and the final gate at level 3. So how many levels do we have? 1, 2, 3. 1, we have 4 main levels at the beginning. Those 2 are ANDed, this is level 2. Everything is ORed, this is level. Now I don't count the inverter. The inverting things are easy, okay? So you start with C ORed with D. C ORed with D, you get the input C, you get the input D, you draw them. D prime plus E, this is D, get the D prime ORed with E. The 2 AND you have ABC, that's ABC straightforward. At A prime BC, you just take the B prime and pull a cable from A and C. You need to pull a cable, okay? And then you OR the 3 big terms. Of course, we ANDed C. Those 2 parentheses, we AND them in the AND this AND gate. Take the output, and this is how it will be. So how many levels we have here, Abu Saud? 3 levels. This is level 1 is to generate those things. Level 2 is to AND those 2. Level 3 is to OR everything. Can we simplify it? Yes, we can. You did this in the lab, so that's example number 2. So A, B prime C plus A, B, C plus C plus D times D prime plus E. So let's start from here. Can we simplify these 2 terms?
Yes.
Yes, if you take A and C using the associative law اللي هو التوزيع, you will end up with B prime ORed with B. How about this? You will get CD prime plus CE plus DD prime plus DE. So C and D prime plus CE plus D ANDed with D prime, always 0, so ignore it. D ANDed with E, not DC, E. What is this? 1, so ignore it. So the final answer is AC plus CD prime plus CE plus DE. How many gates we need for this? We need 1 AND, 2 AND, 3 AND, 4 AND. We need 4 ANDs, 1 inverter, that's 5 gates. So we need 4 ANDs, 1 inverter, and 1 big OR. 1 big OR. Or we can have 2 ORs. Either here 2 input or 4 input. But he's telling you we can simplify it more by taking C as the common factor. I got it in mathematician. We take C as the common factor. We will have C A plus D prime plus E plus DE. And that's the simplest. How many gates we need? 1 AND, 2 ANDs, 1 big OR.
2 or. 2.
Okay, 1 big OR, depending on the question. But here we have 2 OR because we are only allowing the 2 OR, the 2 inputs set. Here you can say OR, 2 OR. This is 1 big OR. Call it big OR, okay? Big OR means more than 2 inputs. If you restrict yourself to 2 inputs, you need 2. And then of course you need 1 inverter. And that's how to solve this problem. Now, again, in the exam we will not give you, we will try to give you examples that are, clear. Some students, if they stop here, some students may have an argument here, but you have to know that taking a common factor is probably a good idea, okay? 2 plus 1, how many gates here? 1, 2, 3, 4, 5. How many gates do you need here? 2 for ANDs? No, 4 ANDs. 2 or 6 plus 1 inverter, 6. So this is cheaper by 1 gate. If we allow only the 2 input gate. Okay, sometimes we give you the circuit, we want you to find the output. For example, A prime ANDed with B ORed with C. A prime ANDed with B ORed with C. This is easier to do. The other example is A and B ANDed, so A, B, there is a big prime, ANDed with C, ORed with C, everything is inverted. If there is a circle after the AND gates, it becomes not an and we call it what? NAND. This is OR, this is NOR. This is OR with a NOT. Okay? If you have a buffer, this is like the op amp. Do you remember the buffer in the op amp? Whatever in goes out. Unity gain buffer. Do you remember unity gain buffer?
Yes.
Forgot the op amp, خلاص. You remember الصادق unity gain buffer? With ratio of 1. اللي ما فيه resistors أسلاك موصل على طول. Read the example of unity gain buffer. They took the example from the logic circuit. So this is A and B, not. Sometimes we just put the dot here. It will be simpler. ANDed with C, ORed with C, everything is ANDed. That's the big AND. So how many negations we have? 2. 1, 2. 1, 2. So if you want to verify your answer, 1, 2, 1, 2. الخط هو نفسه. Sometimes these get simplified, sometimes are not. So let's revise one more time about these properties before we jump into tougher laws. For the AND, what are the properties? We have 4. If you AND with 1 is 1, A. If you AND with 0 is 0. You can swap A and B, and you can do the AND in one group, and then AND everything else, or do the AND in the other group, and AND everything else. For the OR operation, well, for the NOT, we have 2 properties. Everything ANDed with its negation is 0, ونفي النفي إثبات. Okay, يا جهاد? Mr. Jihad, you're allowed. I know you're an abuser, but wanna go? I have a question for you.
So,
What do we need? Yes. What do? Yes.
what about the XOR gate?
We'll get into it later. XOR gates are other gates, not now. Maybe next lecture. Can we do A or with B or with C? What's the difference if you add parentheses versus not in the implementation? If you add parentheses, ya jihad, it means you put it at an earlier level, not necessarily, an earlier level. So to implement this, you do, for example, A with C, this is A with B, or, and then everything, that's another or, you or with C. So how many levels do you have? 2. If you do A or with B or with C, you need a big OR gate. But in the lab, how many gates the gates we had, how many inputs they take? Just 2. So this is big OR, this is small OR. So the benefit of this property is to allow us to use 2 small ORs versus using 1 big OR. Get it? Everybody got it? The last property اللي هي توزيع الآن على الأور, this will be A and it will be OR with C. Okay? Any question about this example? Is it clear? How about this example where we took the reductions? Some students will stop here. But I told you, if you do one more step, you will save 1 gate, assuming that we use 2 input gates. Okay? So stick with the 2 input gate, like that. You can't have more than 1 input in the implementation. All of them are 2 input. 2 input.
On the lab we can put 6 inputs.
No, but you have 4 AND gates in the chip. If you look at the diagram of the chip, you have here 1 AND, here you have another AND.
Yes.
Was it like this?
Yes.
And then here, something like that.
2 inputs, 1 out.
Yeah, and then whatever the output you take, they AND everything together, but the actual AND gate is 2. It's very expensive. This is the last example. Is it clear? Okay. How do you pronounce this guy's name? De Morgan's? De Morgan's law. De Morgan's law, we have 5 minutes left, is basically telling you that if you have 2 variables or 3 variables, if you have 2 variables, A and B, take the 2 negations, A and B, نفي إثبات, so they're the same. He's telling you that I can convert A and B with a NOT to A NOT or with B NOT. And then everything else will go back to AB. The other example, A ORed with B, if you want to find the De Morgan, this is the De Morgan version, is you convert every AND to an OR, and every variable take its negations, okay? How about this? A ORed with B, replace every AND with an or with an and, so this or becomes an and. Every variable, put a negation and take a negation for everything else. Let me tell you the step. Replace every and with an or. Every variable take its inverse, take its or invert it, and everything else has to be. So we usually find the big bars at the end, the big bars at the end. How about this, ABC? Replace every and with an or. A anded, or with B anded, or with C anded, and there is the big nut. Inverted, sorry. So ABC, it will be A prime, or with B prime, or with C prime, everything prime. A or with B or with C, it will be ABC, and there is a nut above the A, a nut above the B, a nut above the C, and there is a big nut above everything else. Why? Because it uses the benefit of Nafi and Nafi Ithbat. We can implement any logic function by using AND gates and inverters, using this. Similarly, any logic function can be implemented with OR gates and inverters. If the variables in the logical expression are replaced by their inverses, so you have to get their inverses, the AND operation becomes OR, the OR operation becomes and the entire expression is inverted. How many steps? 3. Replace every variable with its inverse. Put a bar above every variable. If there is a bar above the variable, remove it. Replace every and with an or. And everything else, don't forget the big bar, okay? Don't forget the big bar. Abdurrahman, how many steps in De Morgan's law? 3 steps. Can you please summarize them?
First, you replace every or with an and.
Yes. Second?
Then you invert every input.
Yes.
And then you invert the
Everything else. Good job.
Not texting.
That's okay. That's okay. We have the last minute. Do you want to do this, or do we want to do it next lecture? Next lecture. Oh, next lecture. What do we have? Quiz 7.1, 7.2. No, alas. Who is planning to be absent? Let me know from now. عادي ما في خصم ولا في شيء. أبغى أشيل الفيديو.